Hello, welcome to the ENCOM Wireless Compact BBN INT presentation. With the Compact BBN INT, there are some concepts that you will need to know beforehand. The first concept is a point-to-point configuration. A point-to-point configuration is the most basic configuration in a wireless link. This consists of one master and one remote. With the Compact BBN INT radios, they are currently available in a point-to-point configuration. They will also be available in a point-to-multipoint configuration. It is recommended to contact your ENCOM wireless representative for further information on the point-to-multipoint configuration. For this presentation, we will be working with the Compact BBN INTs in a point-to-point configuration. The Compact BBN INT has the ability to have a throughput of up to 300 megabits per second. This will be very much dependent upon your line of sight that you have available in your system. The Compact BBN INT operates in the 5.8 frequency band. These radios, once again, are available in a point-to-point configuration currently. Physically, when you look at the Compact BBN INT radio, there are two antennas that are going to be inside of the radio. One of them will be vertically polarized, the other one will be horizontally polarized. It is recommended to have the Compact BBN INT installed at the highest available location of your system, as well as with the Ethernet connectors facing down following the ENCOM installation guidelines. An example application of the Compact BBN INT is as follows. From our traffic management center, we have installed a Compact BBN INT on the rooftop, communicating to the first tower. As noted in the picture, we do have a clear line of sight, and both of these antennas in a real-world application would be lined up accordingly to offer the best available connection quality and, conversely, throughput. From tower to tower, we have the Compact BBN INTs, again, mounted at the highest available location and have been tied into our Ethernet switch. The endpoint consists of our point-to-multipoint system, for example, our 5.8 radios in a point-to-multipoint configuration. We will now proceed with an example of programming a point-to-point configuration with our Compact BBN INT radios. I've logged into Stratos and I have plugged in my first Compact BBN INT radio. From the radio list, I will double-click the radio to log into it and bring up its default configuration. Now, for this example, I have already added in a static IP address, and I will just rename the radio. Once you have set up the IP address, as well as the name you would like to give your radio, you can proceed on to the Radio 1 tab. Under the Radio 1 tab, the radio network setup is the important information we are going to deal with first. By default, as you can see, our network type is a point-to-point configuration, and it will be grayed out. Our network SSID does have to match across our master and remote radio, which I will rename right now. We will be making this a master radio, and in the radio parameter setup, we will be assigning a fixed frequency for this master radio to operate at. The reason why we have a fixed frequency is to minimize any potential interference we would have with other ENCOM equipment, as well as with other 5.8 equipment which may or may not be in your frequency area. After the radio settings tab, you can click on the wireless N tab. The wireless N tab will show you your antenna chains. The antenna chains are a representation of the horizontal and vertically polarized antennas that are internally inside the radio. For this particular example, and for most applications, we would want the transmit and receive to have chains 0 and chains 1 enabled as you see here. This is the default configuration on the radios. This configuration will offer the highest available throughput based upon a clear line of sight, as you'll be using both antennas for your wireless communication. If you would only like to use one set of antennas, uncheck a particular chain. However, please keep in mind that doing so will reduce your throughput on these particular radios. It is always best to leave both chains enabled while trying to maintain a clear line of sight and the highest elevation possible for these radios to operate in. We will now save this configuration to the radio. As you can see from our radio list, the name has been changed as I had desired, and we can see on the right hand side in the item properties the specific information based upon this radio in a quick and viewable format. That is all that is required for programming the Master Compact BBN INT radio. We will now proceed with programming our remote radio. I have disconnected from my master radio, and I have now plugged in my second Compact BBN INT radio. I will now double click the radio to log into the configuration as I did with the master, where I will change its radio name and assign a static IP address. Once the radio name and network information has been entered, you can click on the Radio 1 tab to continue. Just like in our master radio, the radio network setup is where we will start. The only thing we will have to change here will be our network SSID to match that of our master radio. Select our radio mode to be a remote, and we will leave the channel as auto frequency. On a remote radio, it'll always be as auto frequency, as it'll be following what frequency the master tells it to. That is all that is needed for programming our remote radio. We will now hit the save button to download the configuration to our radio. We've now completed the programming of our master and remote radio, and when you look at the radio list, you will now see both of them with a green icon. The green icon will indicate that you do have a wireless connection between the two radios here. When we look at the wireless link status, this panel gives us the information for the signal strength and the connection quality for this particular link. You can see from this example, our signal strength, or RSSI, is approximately negative 60 dBm. This is ideal as we'd like to keep the signal within the minus 50 to minus 70 dBm. Our connection quality is approximately sitting at 80 to 90% on our transmit and receive respectively. For our connection quality, we always aim to have the highest possible connection quality, as that will allow us to gather the best possible throughput on our system here. When we look at the TX-RX rate at the top here, you will notice that it's saying 162.0 HT. The HT actually represents high throughput mode, which indicates that it is operating in the wireless N operation. It is telling us that our raw throughput is currently 162 megabits per second on our transmit and receive. Now keep in mind that for this particular example, you are seeing the TX and RX rates bounce around to the fact that I do not have antennas on my test system. In a real-world application, you will have your integrated units lined up accordingly, and you will see a very clear and consistent throughput. That concludes our presentation on the compact BBN INT point-to-point radio setup. If you'd like to learn more, please visit us at www.encomwireless.com. Thank you.